So there are various changes to the cloth system in Unreal 5.6, and Tim Brakensiek from Epic Games released this document on June 13 that goes through all the changes. And I just wanted to talk through that document because it's easier for me if I've got a video that talks through it all. So in Unreal 5.6, we're giving users the option of using either the existing cloth panel editor or opting into the new data flow cloth editor. Panel versus data flow. Data flow is new. They'll talk through in this document the differences. And it will say later that there's cloth assets, which are existing, and there's outfit assets, which are new things. All right. Unified data flow editor. I don't know why they use the word unified. They seem to refer to the same thing, Dataflow Cloth Editor, in this document in different ways, but it's talking about the same thing. So it's Dataflow Cloth Editor or Unified Dataflow, it's all the same thing. We've ported across the Chaos Cloth Panel Editor to use the general Dataflow Editor framework to allow sharing more features between all the physics editors and accelerate future development. This brings features like subgraphs and variables to the mix. So basically all they're saying is in the new data flow editor, you use subgraphs and you can also use variables. So you use subgraphs instead of functions. We're still working on porting over the last bits from the current cloth panel editor to this more general editor, but you can use it now by right-clicking on an asset in the content browser and selecting Open in Data Flow Editor. You can also enable the data flow editor using the following console variable. So I don't know whether that means, it already is usable, so I'm not sure what enabled means. Does that mean it then forces cloth assets to use the data flow editor as well? I don't know, it doesn't explain it. Note, this is what I said before, when creating a cloth asset from scratch, the editor will still default to the original cloth panel editor, not the data flow editor. All right. New Dataflow Editor Workspace. The new Dataflow Editor features a few new dockable viewports accessible to users when creating their cloth assets. So this just goes through this interface, and you can see that there is a bar across here with Save, Open, Evaluate Dataflow Graph, Cloth Weight Map, Cloth Mesh Selection, Cloth Skinning Transfer, Paint Weight Map, Edit Skin Weights. That's at the top. And then there's all these other areas, but the most obvious ones, it looks very similar to the other editor, the panel editor. So you've got a graph down here, and you've got a 2D and a 3D window, and you've got asset details. All right. And then it says that there's the data flow scene outliner. Scene outliner is a tab, and you can see it says simulation components, cache actor, root scene component, skeletal mesh component, chaos cloth component. So, it doesn't explain any of that. Data flow, subgraphs, and variables. Subgraphs are the equivalent of functions in data flow. They allow you to organize your large graph in a smaller graph and offer to reuse logic. For cloth simulation, they are currently used with the new outfit asset, see below. So this image is just showing you that it says subgraph and then prepare cloth actions, and prepare cloth actions is here as a subgraph, and the icon here is an F, so it still thinks it's a function. Well, it uses the same icon. Then there's a little video subgraph example. Okay, so it's just double clicking on this prepare cloth collection node, and that opens up a subgraph. Okay, Dataflow variable support has been added to the cloth asset. So cloth asset, they're existing things that were already in the engine, and Dataflow variable support has been added to them. Now you can create variables in your Dataflow and override them on your cloth asset. This is particularly useful if you want to use the same Dataflow graph with multiple cloth assets. So the graph can contain multiple cloth assets, and then inside the cloth asset, you can override variables in them. All right, with the newly added variable feature, you can now create parameterized data flow graphs. Each variable supports all the major Unreal types: basic types, structures, objects, and arrays of those. Okay, I'll accept that. And data flow evaluation controls. You can now control how your data flow graph is evaluated. There's two modes that can be selected via the menu options: automatic graph evaluation or manual graph evaluations. So when you open the data flow editor, at the top, you'll see evaluate data flow graph, and then you'll see these three dots. And if you click on that, you can then click on either automatic graph evaluation, which is what it defaults to, or you can change it to manual graph evaluation. Okay, automatic. By default, the graph is automatically evaluated whenever a change is made to it. This can be because a variable changes or a property of a node is changed, or if a connection is made or updated. This is preferred way, as this allows the graph to recompute the resulting asset and all the debug views and inspectors to reflect the changes made. In that mode, the button is disabled. Manual. Sometimes some assets' data flow graph may be too slow to evaluate, or there's a need to make multiple changes before refreshing the views. In that case, the manual mode may be a more suitable solution. When the manual mode is used, the graph will not reevaluate, and the user will need to press the evaluation button in the toolbar in order to refresh the corresponding asset. Overlay icons. The button, so the Evaluate Data Flow Graph button in your ribbon, is going to show various overlay icons indicating the status of the graph. So this means that the graph is out of date with a question mark and needs to be reevaluated. This tick means that the graph is up to date and has no errors or warnings. This exclamation mark and a triangle means that the graph is up to date, but some nodes have warnings. And this red circle with a black bar means that the graph is up to date, but some nodes have errored out. Performance data. So this is an option that you get to if you click on these three dots next to Evaluate Data Flow Graph. And you can see here that is a checkbox that you can enable. And by toggling on performance data, a time in milliseconds is displayed above each node in data flow. So you can see here as an example, above this node, you can see that there's a time of 0.03 milliseconds. Blueprint support. This feature is only available in the new Data Flow Cloth Editor. All right, so if you look at this image, you can see that in the Preview Scene panel of the new Data Flow Editor is a default blueprint class and a blueprint to visualize the cloth asset in the data flow. So this is now exposed to the user, and this allows you to build more complex asset setups than is possible in the older cloth panel editor. And you can see here, this drop down, you can browse to a different asset if you want to. And this BP outfit preview is down here. I'm not sure why this says cloth preview and this says BP outfit preview. Best practice using this blueprint is to make a copy, assign the new copy to your data flow. Oh, I see. So this is the original cloth preview maybe, and the copy they've made is outfit preview. I don't know. Assign the new copy to your data flow and save locally in a user directory. You can then edit as needed without modifying the engine content. And this is an image of the default cloth asset blueprint, and this is of BP_outfit preview. All right, outfit asset. A new outfit asset has been added that allows assembling multiple cloth assets and other outfit assets together to form complex simulated clothing. All right, so an outfit asset can contain cloth assets and it can contain outfit assets as well. Any outfit asset created will use the new Data Flow Cloth Editor. This feature is experimental and requires a plugin to be loaded, so the Chaos Outfit Asset plugin. To generate an outfit asset, you use the same process as when creating a cloth asset. So in the content browser, right-click and you pull down to Physics. So you can see here it goes Physics and then outfit asset. As soon as the outfit asset is generated, a prompt will open. Select a template for this newly created outfit asset, and you've got no data flow, empty data flow, simple outfit, resizable outfit, resizing graph. The default selection will be simple outfit. This adds a data flow with a simple cloth asset graph, allowing to simulate multiple cloth assets from the same Chaos cloth component. So it's showing you've got this cloth asset node here, and a make outfit node, and then an outfit asset terminal node. Then it says simple outfit with variable overrides. So it's saying that you've selected this cloth assets node here, and over on the data flow members tab, you've gone down to variable overrides and you've enabled cloth assets here. And in theory, you'd be adding things here. Resizable outfit. So it's showing this template here. So when you first make an outfit asset, and then it pops up and you click on this resizable outfit. So this adds a data flow which builds a single resizable garment from multiple cloth assets. Body sizes need to be user provided in addition to the multiple cloth assets. So you need to provide your own body size to make this work. And you're seeing this is the resizable outfit node. This template includes 2 functions and 2 subgraphs. Oh, it's got functions and subgraphs. Oh, so that's very confusing. Used to calculate the resizable outfit template. So this says subgraphs, but these are actually functions. He's referring to these as functions, but earlier it called these subgraphs that had the F. Is it a subgraph or a function? I don't know. Maybe subgraphs and functions are both referred to as subgraphs. It's a brave new world, people. It's a brave new world. Resizing graph. This template is used to test a resizable outfit asset. Test. I don't really understand what that means. Resizing graph here. So you make a resizable outfit here and you test it here. What? This data flow contains subgraphs and functions used to correct sim and render mesh skin weights, as well as provides for aligning UVs. Resizing graph default subgraphs. So these are the subgraphs, which are sometimes functions, that the resizing graph template contains. Get cloth collection, resize, correct sim skin weights, correct ren skin weights. I mean, what? So wouldn't the resizable outfit have things inside it that are fixing skin weight? I don't understand what this means. Oh, because it's a bit like a Russian doll, everything fits in another. Okay, so in theory, you make a resizable outfit, finish that off, and then you make a resizing graph, which you then link to your outfit. So you choose your resizing outfit that you've made, and then you can adjust things and stuff. So I'm assuming the resizable outfit doesn't contain prune skin weights, relax skin weights, hammer skin weights, clamp skin weights, normalize skin weights, resize UVs, blah, blah, blah. There will be more detailed documentation about the inner workings of the various outfit asset templates in a future tutorial. Oh, good. Because Toby's confused. Always. I'm always confused. Cloth refitting. Cloth refitting is a new system developed in collaboration with the MetaHuman team to support scalable dynamic clothing in the MetaHuman character pipeline. The system allows cloth assets to resize intelligently across a broad range of body types and integrates tightly with the updated MetaHuman creator workflow. Version 5.6 introduces new nodes that allow resizing of a cloth asset from a source mesh to target one using RBF, radial basis function, based logic, and is located in the resizing graph outfit asset template in the above section. And this is showing a node get outfit RBF interpolation data. And now we have a video. I don't understand what this is showing us. It's showing us the effect of resizing. Okay, fine. Cloth constraints, experimental. It is now possible to define constraints bound to different parts of a cloth asset. This can be used in many different ways to better control the behavior of the simulation. It can also be used as a complement or replacement to the more expensive self-collision. So cloth constraints are an alternative to self-collision. Okay. Separate compression and extension stiffnesses can hold sections apart while allowing the free motion of the simulation mesh. So the red part of the fabric is piercing inside the blue part, and it should be outside. And it's saying after the cloth constraints, the red is outside where it should be. Cloth-to-cloth constraints are featured in two new nodes. You need source and target selections based on either face or vertex, depending on which node is being used. All right, makes sense? Simulation cloth vertex face spring config. This node is used for creating vertex to face constraints. And this one is for creating vertex to vertex spring constraints. So vertex face and then vertex to vertex. With the selections connected and settings in the node details adjusted, the step to create the actual springs is pressing the Generate Constraints button. The example of the dress above uses 3 sets of selections using the Simulate Cloth Vertex Face spring config node. All right, so it's using vertex face instead of vertex spring. Fine. The selections are outer verts, inner faces, outer faces, inner verts, inner faces. Okay. Here we go. We got some showing these selection nodes. Fine. So this first selection node is selecting outer vertices. And this second node is selecting inner faces. And this third node is selecting outer faces. And this fourth one is selecting inner verts. To visualize the cloth constraints, check the cloth constraints toggle in the Simulation Visualization tab of the Visualization Details preview window in the Dataflow editor. Kinematic Skinned Triangle Mesh Collider. You can now use a skeletal mesh as colliders for your cloth simulation, allowing for triangle level collision. You can create a skinned triangle mesh by right-clicking in the Physics Asset Editor and selecting Generate Skinned Triangle Mesh. It will generate the collider using whatever preview skeleton mesh and LOD that you currently have selected. Its performance scales with the complexity of the underlying skeletal mesh, but it can be used in real-time scenario as well as offline simulations. Note that the resulting mesh generated using this process can slow down your simulations considerably. We recommend starting with a LOD2 type mesh setting. The panel cloth knows how to use these physics assets, and the controls for collisions live under the simulation collision config node, not the simulation self-collision config node used previously for the Kinematic Collider introduced in 5.4. Set your saved physics asset in the Set Physics node in Dataflow and toggle collisions in the Simulation Visualization tab to see the result. And chosen it. So they've got one here that says PA mannequin cloth faces as the physics asset. So that was obviously a kinematic skinned triangle mesh collider. Note, the Kinematic Collider in Dataflow will continue to be supported, but any new related features will be directed to this new physics asset-based workflow. Okay, so they're still going to support the Kinematic Collider, but it's not going to have any new features. This is the way forward, people. Simulation collision config updates. All right, so then this post goes through new updates to this node, the simulation collision config node. So if we clicked on that, we'd see these options here, and it's telling us that there are a few additional new features. Collision thickness is the added thickness of collision shapes. Friction coefficient, the coefficient for cloth to collider friction interaction. Only skinned triangle meshes use this weighted value. All other collisions use the low value. Enable simple colliders. This enables colliding against simple colliders, which are capsules, convexes, spheres, and boxes. Use planar constraint for simple colliders. So this is an option that you can enable, and this is cheaper than full collision detection, but it's less accurate. Use complex colliders. Enable colliding against complex colliders, which are the skinned ML level sets. I don't know what that means. Use planar constraint for complex colliders. They're cheaper than full collision detection, but less accurate. Enable triangle skinned mesh collisions. Enables collisions with triangle skinned meshes. Blah, blah. Use self-collision substeps for skinned triangle meshes. Use num self-collision substeps located on the Simulation Solver config node to control skinned triangle mesh collision. Cloth collision thickness. Thickness added to the cloth when colliding against collision shapes. Only skinned triangle meshes use the weighted value. All other collisions use the low value. Use CCD. Use continuous collision detection, CCD, to prevent missed collisions between fast-moving particles and colliders. This has a negative impact on performance compared to when not using CCD. Velocity scale node improvements. So this is the simulation velocity scale config node. 5.6 brings more parameters to users when working with acceleration and velocity of cloth simulation on characters. Updates include control for how much movement is inherited from world space, both linear and angular control, clamps for velocity and acceleration. All of the following vector properties for this node will be evaluated in one of three different spaces. Oh, it's showing world space, component space, and reference bone space. Okay. Linear velocity scale. So that's this thing here.